If someone has to give the response, PPT is visible?
Yes, sir.
Yeah. Yeah, now the PPT is visible. Material properties, the slide. If someone has to give the response.
No, sir.
So only that
PPT is
window
not-
is visible, sir. Backside windows, desktop is visible.
Desktop is visible. PPT is not visible?
No, sir.
No. Okay, 1 minute. Now PPT is visible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. A material property. The slide name is material properties, right?
Yes, sir.
Yeah. Okay. The last class we discussed about, so what are material properties? In that we discussed about mechanical properties, right? Now why do you want to know the mechanical property means? So we should know how the body behaves, how material behaves when it is subjected to an external force. If I know the body, if you know how the body behaves when subjected to external force, then you can easily use that material for our engineering applications, for our engineering components. That's why we should know the material property in that mechanical properties, right? This is the first question I asked, right? So some of the mechanical properties are strength, stiffness, elasticity, plasticity, machinability. Machinability means it has to convert the raw material into a semi-finished or finished product. Next, ductility, brittleness, malleability, toughness, resilience, creep, fatigue, and hardness. Right? Strength nothing but is the ability of material to resist the load without undergoing its excessive deformation or without undergoing any failure. That my ability called as a strength. Again, we have a depend upon the type of load acting on the component. We can name it as a tensile strength, compressive strength, shear strength, yield strength, ultimate strength. Right? Again, stiffness are nothing but the ability of material to resist the deformation induced to load. Yes. Please mute yourself. Okay, the stiffness are nothing but the ability of material to resist the deformation ability of material to resist the deformation induced due to an applied load. That is called as a stiffness. As you know that the strength formula is nothing but it is related to a stress only. Stress is equal to load by area. Strength is also same formula. Is the load by cross-sectional area. Stiffness are nothing but load by deformation. Okay, it's the ability of material to resist the deformation when applied and subject to an external applied load. That is also called as the rigidity. These two are very important. When you go for design any component, first we should know design against strength. Second one, design against stiffness or design against rigidity. What do you mean by design against strength means whenever the load applied on a component, the stresses are induced in the component, the induced stresses are less than the hollowable strength of the material. Then you can say the design is safe, or design of the component is safe. Second, design against rigidity means, again, when a external load applied on a body, the body undergoes change in dimension, deformation takes place. The induced deformation should be less than the allowable deformation. Then we can say the design is safe, right? These are two very important property when you go for design a machine element or any aircraft structures or spacecraft structure. First we go for design against strength, another one design against rigidity. One more is there, later we'll come to that one. Okay. Next, hardness is a measure the ability of material to, it measures the resistance to penetration or indentation or abrasion. Next, ductility, ability of material to deform under tensile load, continuously deform. Examples, wires. Malleability, ability of material to continually deform when what type of load here? Compressive load, become sheets, right? Elasticity, ability of material undergo deformation when load is applied. When you remove the load, it comes back to original shape and size. Plasticity, permanent deformation. When you apply a load, it undergoes permanent deformation. When you remove the load, it will not come back to original shape and size. Then fatigue is a maximum stresses induced can withstand under repeated cyclic load. Best example in our home appliances, if you take a switches, electrical switches or regulators. So in a best example, electrical switcher, each time you're going to make switch on and switch off. That is called a cyclic load, right? That after some years or some days, the switches will fail to do its function, right? That is one best example for fatigue. Next, creep. Creep means is a time-dependent parameter. The whatever the stresses induced in the mechanical stresses induced on the component on time-dependent parameter, right? That is the ability of material to deform permanently under the influence of mechanical stress. It occurs as a result of long-term exposure to high levels of stresses. Okay. Next, resilience means when you apply a load, the energy is stored in a body, okay, within the elastic limit, that is called as resilience. Modulus of resilience means per unit volume we consider the strain energy stored in a body per unit volume we call as the modulus of resilience. Up to elastic limit you consider here up to point A or sorry up to point B, you consider what is the area under this curve here. It's a triangular shape, half into base into height, that you can use here. Then you will get this formula, resilience formula. Toughness means area under the curve, this complete stress strain curve, elastic region and plastic region. That is called as ability of material to absorb the energy when deformed elastically and plastically. Right? That is called as the toughness with respect to unit volume we define here. That is called modulus. Next, next one is brittleness. As PPT is visible,
Yes, sir.
someone has to give.
Yes, sir.
Okay, brittleness, right? Yeah, the brittleness is nothing but ability of material breaks with a little elastic deformation. Means without undergo any elastic deformation directly, and the plastic deformation also not takes place, it failures occur. Okay, that is called brittleness. As you know, the example of brittleness is ceramics, glasses, cast iron. And these are some examples what we given in the last class. We studied mechanical properties of materials, right? Now in the next lecturer, in this lecturer we are going to study the mechanical members, or called as aircraft members, also aircraft structural members. Here are called as mechanical members. The first mechanical member is called as bars. So what are bars are nothing but, if you consider a member is subject to only axial load, it may be a tensile. You consider the member is subject to only axial load, it may be a tensile or compression. Those mechanical members are called as bars, right? Best example I consider human body. Whenever you study the topic, first we apply ourselves, and you can see our home appliances. Then you go for see the industrial appliances or environment. Best example I can take here, human body. For human body, you can take human body. Yes, is visible. Yes. Someone has to give the response.
Yes, sir. Human body visible.
Yeah, human body. See that. If you take human body, our arms, our hand. See the in arms are, this is the one part of a body. We apply a load here. Now the arm is subject to what type of load? Axial load. Right? Now that is called as a bar record as. But don't, this is a for understanding purpose I'm giving here. Okay? For mechanical members, you come here, a steel rods, telescopic arms. What are the steel rods? You can see in the sketch here. That is used for construction purpose or to manufacture, to make a mechanical component such as a gates, okay, or windows, where we can use the steel rods, right? The steel rods, how do you fix the steel rods in the windows or in gates? By applying an axial load, right? Right? It may be tensile or in compressive nature. Those mechanical member record as a bars. Now remember, bars are nothing but members are mechanical members subjected to an axial load, only axial loads. Okay. Telescopic arms, you can see the telescopic. Okay, sorry. Telescopic arms are, that is what we use in lifting the vehicles, for lifting the what is the oars, etc. in cranes. You can see the telescopic arms, right? Or with the object, the stars, moons, then we use a telescope, right? How do you fix it? We'll go for extend that arms, right? Those are also called as what type of load acting on the component here? Axial load, right? Those are also called as a bars, right? There are different types of bars are there based on the cross section. If it is throughout the length, is the cross section is same, the diameter is same, then that bar is called as a straight bar or uniform cross section bar. You can see in the first picture, throughout the length, the cross section of the steel rod is same. Okay, that is on the circumference. You can see that is for use for gripping purpose. Okay, second one is tapered bar. You can see the second figure here. This is called as a drill bit. The shank of the drill bit here, it is tapering cross section, means continuously the diameter is decreasing, or from this end you can see here continuously the diameter, the area is increasing. That is called as a tapered bar. It may be a circular tapered bar or it may be a rectangular tapered bar. Right? Best example for tapered bar, I think you have seen in the home appliances. I want to fix the wall clock on the wall. Then first you probably make a hole. On that we use a wooden the piece, right? The wooden piece first you fix there, right? Then you go for hammer it. The wooden piece is like what type of bar it is here? Tapered bar. It's a rectangular cross section or it may be square cross section also. Right? The stepped bar, throughout the length, the cross section is not constant here. See that in the third picture, throughout the length, the cross section is not constant. Here is the one diameter, this is another diameter. Here also is one diameter here, key base here. Third one comes here, it is a rectangular cross section. Here it is circular cross section. Right? Now these are the different types of bars. Right? Any doubt regarding this one? First mechanical member bars. Yes. Best example for bars I can give here, your bicycle. In the bicycle, the suspension of the bicycle, right? That is also a subject to what here? The mechanical member subject to a compressive load. Is a bar only, right? Bicycle or motorcycle. Okay. Next comes here another mechanical member will called as a truss. Trusses are nothing but a member subjected to any type of load. It may be axial, it may be inclined, it may be a transverse or combination of all the loads. But where it acts here load here, load is acting at the joints. That is called as a truss. Now axial means along the axis of the member you are applying load. It may be tensile or compressive. Inclined means with respect to axis, the load is not parallel to the axis. It is at an angle, that is called as inclined load. Transverse load means if the load is acting perpendicular to the axis. Now consider this is geometry, the axis is here horizontal. What we are applying load here? Perpendicular to the axis, that is called as a transverse load. Or combination of all the loads, axial, inclined or transverse. That is called as a where you acting where the loads are acting on the member here at the joint. Those mechanical members are called as trusses. Best example for trusses, see the roofs of houses, right? See the roofs of houses. These are trusses. How do you represent here? Even in the toll, also you can see the roofs of that. The what is the structure they mounted in the tolls, right? Or if you take the high transmission tower lines, high transmission tower, right? Electrical energy transmit here. They will use high transmission towers. Then if you go for bicycle frame also, the frames, the body of the bicycle is also comes under, there's a called as a frames actually. The frames is almost similar to the what is a trusses. Again, you can see this for the images what I am highlighting here. Okay, so Aradhana,
Sir,
yeah. Now you can see this fourth picture here. What I am highlighting here,
yes, sir, bicycle.
a bicycle. When a person ride the bicycle, right, are cycling here. Now you can see the which mechanism it is here.
Uh,
What about the when it's
Sir.
pedaling here? It goes under complete rotation, right?
yes, sir.
Yeah, that is called as a crank. Yes or no?
Yes, sir.
Yeah. Now what about the leg here? Leg undergoes oscillation, rotation and also oscillation, right?
Yes, sir.
Yeah. What about this one here? From the leg here, what is called as it is? From here to here it is. Yes.
Yes,
This
sir.
undergoes what? Again oscillation. This is a link is fixed link here. Now what type of mechanism it is?
Rotation.
Yes, anyone can give the answer? Which mechanism it is? I think already studied in your kinematics of machines. Yes. Nitasha? Nitasha? Okay. Now this is what type of mechanism here? Here a crank, here it is rocker, crank rocker mechanism. This is actually a 4-bar mechanism, right? So pedaling is undergoes a complete rotation is a crank. What about this here? Okay, the leg, the upper part of this here, like it undergoes here a oscillation. The crank rocker mechanism is a 4-bar mechanism, right? Again, the each part again subject to what type of load here? This is the bicycle frame actually I am considered here. This comes under trusses here. Okay, right? Okay, so unmute, so mute yourself. Next, so the first mechanical component you called as a bar is subjected to only a axial load. Second one is called as a trusses subject to any type of load at the joints. Now third mechanical member we call as a beams. Now how do you define beams are? The beams are slender member. Now why do you call it as a slender member? So if you consider, okay, I'll take this itself example. Slender member means as compared to cross-sectional dimension, the width and the thickness, the length is more. Okay, the length of the member is more as compared to cross-section of that member. Then that member is called as a slender member. Right? A slender member is subjected to only what type of load here? Transverse load and movement. Transverse load means a load acting perpendicular to the axis. That is called as a transverse load. And the movement. Movement are nothing but for if you have apply a load here, it tries to bend like this. That is called as a movement. Door, also handle of the Almirah doors. Some doors handle of the doors, you can apply a moment, right? So a slender member subject to either transverse load or movements under movements. Then those members are called as beams. The applications of beams are mainly used to support the floors and ceilings of the building, pipes carrying water, shaft supported bearings, machine beds. See that in this picture here. Now water beams are there. Now vertical components, and this is not a beam. This is a pillar we call as. They called as a column. Later we'll come to that one. Now these are called as the horizontal. What we see here, those are called as a beams. In the building also you can see the beams. Carries what type of load here? Transverse load. Okay, members subject to a transverse and or a movements. Those mechanical members are called as beams. Instead of take a building of bridges, you take a ceiling fan. Again, ceiling fan is also comes under what is the wings of the ceiling fan. Or if you consider an aeroplane, the wings of the aeroplane or tail fin, those are all also called as the beams. The aircraft structures, the aircraft structures also the wings of the aircraft is also a beam. Why do you call it as a beam here? You can see that this is a slender member, means the length is, the dimension of the length is more as compared to cross-sectional dimension. And what type of load acting here? You can see these two are gas turbines, right? The gas turbine load acting vertically downward, means on the beam the load is acting here perpendicular to the axis of the member. Now the aircraft wing called as a one type of beam, that is if the one side of the beam is fixed, it called as a cantilever beam. Later we'll study that. So types of beams. Okay. Now the aircraft wing. Similarly, go for fan. The wings of the fan, the blades of a fan, or blades of any turbine you can take. Those are all comes under beams, right? Any doubt regarding this topic? Bars, trusses, beams. Now some of the examples. Yes. Yes. Any doubt?
No, sir.
Okay. Some of the examples for beams are aeroplane wings, railway track. You can take the railway track. Again, so what type of this railway track? You can see that at the bottom they give the support here. Over that, the railway wheel vehicles are passed by, right? That is the railway track is also a beam. Or toll lever. If we take a toll lever also is a beam, right? Then chassis of vehicle, take any vehicle, is a 4-wheel vehicle or 6 or the buses or lorries, the chassis. Again, if you consider this a chassis, the wheels are there, they supported the chassis. What type of load acting on the chassis here? Perpendicular to the axis of the chassis. That is a transverse load. Transverse load. Okay, that's the beam. Now all the flyovers, video is recording, sir. All the flyovers, all the flyovers, you can see that again vehicle is passing over the flyovers. The weight of the vehicle is acting on the flyover is perpendicular to the whatever that flyovers, that the weight of the vehicle acting perpendicular to that the component. That is and another one is a handle, door handles. If you take a door handles, that is also a beams. If you take a shaft, any rotating shaft, okay, railway wheel axle. I think you see the railway wheel axle or vehicle wheel, the rear wheel or front wheel to 4-wheelers or buses or trucks. The axle itself acts as a beam because the transverse load is acting on that. Then blades of the turbines or fans, compressor, etc. So these are the examples for the beams. Beams are nothing but it's a slender member. Why do you call it slender? The length of the member is more as compared to the cross-sectional dimension. Then it called as that member is called as a beams. It is member is called as slender member. It's subject to a transverse load, means the load acting perpendicular to the axis. That is called as a transverse load, or it's subject to a movement as a movement. Okay, that member is called as a beams. Next, another one is shafts. Shafts are nothing but is a cylindrical subjects. I think you have seen in your bicycle, motorcycle, cars, buses, railway wheels, right? Okay, then are also in where we see again mixer, grinder, washing machine. You can see these are the cylindrical members that are subjected to what? And are subjected to a torque. That are subjected to a torque means twisting movement. This PPT is visible.
Yes, sir. Visible.
Something went wrong.
Huh? Visible now.
Is my is audible?
Yes, sir. You're also audible.
PPT is visible.
Yes.
Yes. Okay, but I'm not seeing PPT. Okay, 1 minute. Yeah, now PPT is visible. Yes, someone has to give the response.
Yes, sir.
Yeah,
Yes,
slide
sir.
number is shafts, right? The name of the slide is shaft.
Shaft.
Yeah, okay. So shafts are nothing but is a cylindrical member. Cylindrical means is a circular cross section. It is a what type of cross section? A circular cross section. It is subject to a twisting movement or a torque. Then it undergoes a rotation, right? Those members are called as a shafts. Now, where we see in this shaft, you can see that this is a one is propeller shaft. Okay, that's a propeller shaft of. Okay, this is what is IC engines in multi-cylinder IC engine. This is a crankshaft. This is a steam engine shaft. Now you can see the blades, the wings of the steam, the turbine, steam turbine, and most whatever the aircraft engine, the jet planes. You can see what type of shaft it is. It is a propeller shaft of aircraft. Right? The shafts are nothing but is a cylindrical member. It's subject to a twist or a torque that makes to rotation, right? Those cylindrical members are called as shaft. Some of the examples for shafts are drive shaft of an automobile, a transmission shaft, the propeller shaft of a ship or aeroplanes, or railway wheel axles. Now the shafts are two types here. Is a usually shafts are circular cross section only. It's either it may be a solid or tubular. Solid means a completely the circular cross section having a solid material. There is no gap here. Tubular means hollow. It have an outer diameter and inner diameter. Those mechanical components are called as shafts. Next one is columns, but actually it is not there in your syllabus, but heading is given, the shafts and columns. Okay, columns are nothing but these are also a slender member, means the length is more compared to cross-sectional dimension, but subjected to what type of load? Only compressive load. When it is subjected to compressive load, now it will failure due to buckle. Buckle means what? Initially it is straight. I think you are visible. This was the model. If you apply compressive load, what happens? It failures due to it will whatever the initially it is straight. Now it is will become a bend like this. This is called as a buckle. Okay, it is deflected. Then it failures due to a deflection, lateral deflection. That is called as a buckle. Right? Those mechanical members are called as columns. Now these are long, slender structural member loaded axial compression. It may deflect laterally and fail bending rather than fail by direct compression. If it is fail by direct compression means those members are called as a bars. If not deflected by the compression deflected, it is a failure due to a lateral deflected. Means perpendicular to the axis, it is deformation takes place. That is called as a deflection we call as, right? If you failure by a lateral deflection, then it's called as a columns. Best example for column, you can see the water tank, the pillars of water tank, are pillars of the building. Those pillars we call as a columns because it is a long, it is what we call as is a slender member. Length is more as compared to cross-sectional dimension. Then what type of load you are acting here? A compressive load. You can see the picture number 1 and 2. Even this is what we call as a skating scooter of a right skating scooter. You can see that once here load is applied here compressive load, but what about this pole is here? It is subjected to what? A compressive load. This is called as column. Some of the examples of columns are water tank pillars, building columns, connecting rod. Even connecting rod also subject to a compressive load. right? Then two-wheel vehicle suspension system, vehicle lifting devices such as screw jacks, okay, etc. Those are mechanical members comes under columns, right? Any doubt regarding these five mechanical members? One is bars, a mechanical member subject to only axial loads. Second one is trusses, a mechanical member subject to all types of loads occurred at joints only. Third one is beams, a mechanical members are subject to a transverse load or external movement. And fourth one is a shaft. The member is a cylindrical member is subjected to a torque, is a twisting movement or a torque. It tends to rotate. Those are called as shafts. Then last one is columns, is also a standard member subjected to a only axial compression. Axial compression, it failures due to a lateral deflection, means the deformation takes place perpendicular to the axis, okay, and failed by bending rather than failed by direct compression of the material. They're called as columns. These are five important mechanical members you should remember. Yes, any doubts regarding these mechanical members?
No, sir.
No. Okay, thank you, ma'am. Now just I'll give some example. What are the again some other also mechanical members are there, but subject point of view, I listed only five members here. Okay. Now I'll come to the syllabus. Now what your syllabus tells that? Okay, in mechanics of material, subject code is 18 AS 33. Already you know that what is 18 is the 2018 scheme. AS means the branch name, aerospace engineering. Next 33, first three stands for semester. You are in third semester. Next three stands for the name of the number of the subject is the third subject, right? In that you can see the syllabus. Okay, power is off. Okay, in that you can see the syllabus. What is the first module says that? First module will study the basics of linear elasticity. Is the first main topic. What is the linear elasticity means? Whatever the material will consider, up to elastic limit only consider. Means if you apply a load, it continuously deform. If you remove the load, it comes back to original shape and size. That is called elasticity, the linear elasticity. In the stress strain diagram, up to elastic limit, we only consider. In that, what will come here? Simple and compound stresses. Simple stresses are means we are applying a direct load. If you are applying a tensile load means tensile stress you will get. If you apply compressive load means compressive stress. If you apply shear load means tangential load means shear stress you will get. Those are simple stresses. Compound stresses means a member subject to two or more loads. Consider a member here is subject to a tensile load. Okay. At the same time, a transverse load also occurred, or inclined load is occurred, or eccentric load is occurred. Then that's called as a compound stresses. In the first module, we are going to discuss what do you mean by stress, strain, types of stress, types of strain, the mechanical properties of material, right? Then stress strain relationship, then stress strain diagram, okay? Then how do you calculate the stresses and deformation? In the what type of component we will consider here? We will consider only a bars. Here the stresses induced on what type of component here? Consider the component, mechanical component is bars. Means the member is subject to only a axial load. Simple stresses and also compound stresses also. But compound stresses, two or more stresses are acting. Apart from bar, some other components also will come here. Okay, this is simple stresses only for here, not compound stresses, bars. Compound stresses, other components will come here. Okay, that is the first module deals with. The first module deals with, we are going to understand about what do you mean by stress, strain, types of stress and strain, then stress strain relationship, stress strain diagram. That is stress strain relationship we'll get from the generalized Hooke's law. Hooke's law. Stress is linearly proportional or directly proportional to strain. Then mechanical properties of material, etc. Then you calculate a simple stresses by considering a bar. Bar is subject to tensile load, compressive, how the bar is deformed, whether it is maybe a uniform bar, a tapered bar, or stepped bars. Compound stresses are that is related to a member. Here consider a two-dimensional member or the plane. On the plane, what is the stressor acting? It may be tensile or it may be a compressive. Another direction compressive is there. One direction is tensile is there. Then you go for determining the stresses and deformation induced in the component. Two or more stresses acting on a component is called as the compound stresses. That is in detail we'll discuss in module 1. When it comes to module 2 deals with now what type of mechanical members we'll consider here. It is a beams, means a center member subjected to a transverse load. If the transverse loads occurred here, what happens if transverse load occurred on the component, means on the cross sectional area, what type of forces act here? Perpendicular to the cross sectional area, right? So tangential to the surface area, means is a shear stresses induced here. Shear forces are induced. Then at the same time, transverse load tries to bend the component, means bending moment is occurred. Right? Bending moment is force into distance. Shear force, the transverse load that causes on the cross sectional layer is a tangential, is a surface, tangential to surface, right? Acting on the component, that is called as shear force. I want to know the what will be the shear and bending moment occurred on each throughout the length of the component beam. That we draw the shear force and bending moment diagrams that we studied in the module 2. After that, Euler-Bernoulli theorem also we applied. Okay, there is a scientist name Euler-Bernoulli theorem. Then calculate what are the stresses are induced. Here, what type of stresses induced in the beams here? One is, okay, if the beam is bent here, it undergoes induced at the axis. Stresses are 0. That is called neutral axis. Above the neutral axis comes to tensile stresses. Below the neutral axis, compressive stresses. Right? Bending stresses are occurred. It may be tensile or compressive nature. At the same time, shear stress also occurred at the cross section. Those things will be studied in the Euler-Bernoulli beam theory. Now in the module 2, which mechanical component will consider here? Beams. Comes to third one. In module 3 also we discuss in first part beams only. Here, when the transverse load occurred here, initially the component is straight. If one end is fixed here, if a transverse load occurred here, what happens? The beam is deformed perpendicular to the axis. That is called as a deflection. Right? If the member is there, an axial load is occurred here, the change in dimension takes place along the length. That is called as a extension, elongation. If it is decrease in dimension along the axial direction, that is called as what we call as shortening its length. Right? If it is the deformation takes place away perpendicular to the axis, then it's called as a deflection. Now, how much deflection takes place in the beam, that we will study in the deflection of beams by using the second integral method or Maclaurin's equation. And second part in the module 3 here, we will discuss. We are going to study the shafts. The mechanical member is shaft. A shaft is subjected to a twisting movement or a torque. How much power is transmitted? How much shear stresses are induced? Those things we study in the torsion of circular shaft. But in syllabus they given heading elastic stability of columns, but there is no content as given in the syllabus. There is no content in the syllabus related to columns. That's why I'll put in red color here. Okay, we'll discuss in the aeronautical branch that same subject also there. If you have a syllabus, we will continue this one. But just I'll give overview for this elastic stability of columns. Columns are nothing but is a slender member subject to only compressive load. It failures due to what? Buckle, not due to compression. It failure due to buckling. Okay. This is the module 3 discussed. In first part discussed only deflection of beam. In second part torsion of circular shafts and columns. Comes to 4th module. In the 4th module, virtual work principle. What is mean by virtual work? Virtual means imaginary. Work is nothing but, they say physical work is nothing but force into displacement. So if a force into displacement occurred on the component, this work has to be done by the object. But here, what type of work here? Imaginary work. Okay, imaginary work, a virtual work. Okay, in the virtual work principle, again it mainly discussed, okay, in detail we'll discuss in later. Next one is energy method. So in the module up to module 3, whatever the mechanical members you consider, it may be bars, beams, shafts or columns. There when external load is applied, then we determine how much stress is induced in the body, how much deformation takes place in the body. That is our intention in the subject, right? But how do we determine? Here we apply exact mathematical formula, direct formulas. But in energy method, we use energy methods such as how much energy is stored here, strain energy stored, that is considered resilience. We are expressing how the body behaves in by telling that how much energy is absorbed by the body and is subject to an external load. That is called energy methods. That is called strain energy methods here. Then last module we'll go for discuss here mechanical properties of material. I think already we discussed these mechanical properties. In that he mentioned only 3 property. One is fracture, second one is creep, third one is fatigue. Fracture is nothing but is intended to fail to do its function, right? So for example, if you take a building, how the building collapse here? First, initially the building, whatever on the walls, on the or in columns, you can see the cracks. There is the first stage of fracture. Crack is occurred. Again, if you increase the load, the crack is propagated. That is the second, the failure. Once the crack is propagated, finally it becomes a rupture. There is the third stage of fracture. First stage is initiation of crack. Second stage is crack propagation, and third one is the rupture or failure. Best example, you can see the buildings, right? First you see the in buildings, first you can what we can see the cracks, as you can see that then crack is propagated through the walls, then finally the breaks, rupture is occurred. That is called as the first one, fracture. Creep is nothing but is a time dependent parameter. If the constant load is occurred on the component, then permanent deformation takes place, then failure occur. Again, here also 3 stages are there. One is primary stage, secondary stage, and tertiary stage. Okay, in detail we'll discuss here. Next, last one is fatigue. When fatigue comes here, when mechanical members are subject to a cyclic load, the failure of a member takes place with cyclic load, that is called as a fatigue. Right? Within the yield strength only, the material failure, that is called as a fatigue. Again, module 5 is only theory part. You can easily score as an exam point of view. You can easily score out of 20. Okay, 16 marks you can easily score. This is only a theory part. No other formulas or derivations, etc. But from 1 to module 4, you can see that theory part also will come. Derivation is also there, and you have to solve the problems also. Clear? This is your syllabus, complete syllabus of your mechanics of material 18 AS 33. Yes, any doubts?
No, sir.
No doubt? Okay. Next, we'll go for start our first module. Already we started the first module. Already you know what do you mean by stress, right? Intensity of internally distributed load occurred over a cross-sectional area you call as a stress. That is a physical meaning. Then how do you mathematically represent stress? Stress is equal to load by cross-sectional area. Then how do you represent symbolically? Stress we represent as sigma. There is a normal stress we represent sigma. Load is, it may be a F or P. The cross-sectional area is capital A. The unit of stress is Newton per mm square. Right? Based on the type of loads occurred on a member, it defines the types of stresses. One is tensile stress. Second one is compressive stress. The tensile and compressive stress is also called as normal stress. And third one is shear stress, a tangential force acted over the surfaces of the surface of the member. That's called as a shear stresses, right? These are the three main stresses: tensile stress, compressive stress, shear stress. And other stresses also there, such as one is the bending stress, it may be tensile or compressive. Second one is a twisting or a torsional stresses, that is a shearing stresses. And one more is a bearing stress. One component placed over the another one. Then the second component is the bottom component is bear the load of the top component. That is called as a bearing stresses. Already we discussed the types stress and types of stresses. Similarly for strain also, before going to define strain, in a body subject to an external load, when change in dimension of the body takes place due to an external load, then it is called as a deformation. The deformation to the original deformation, the change in dimension to the original dimension, a change in that we called as a strain. Again, types of strains are, one is the change in deformation takes place along the axial direction or along the loading direction is called as a longitudinal strain. Perpendicular to the loading direction or perpendicular to the axis is called a deformation takes place called as a lateral dimension. The change in shape of a body due to a shear load occurred on the body then is called as a shear strain. Then we discuss the stress strain diagram, right? Yeah, mechanic, yeah, stress, strain. Next, we discussed about stress strain diagram for we consider a low carbon steel. So, a low carbon steel, that is a mild steel we consider here. How the stress is depend upon the strain. That is stress strain curve. You should remember this one. Okay, what are the salient points? Salient points are A, B, C, D, E, F. Those are called as salient points. Means the study point. We will call as salient is nothing but a study point. Okay, we are going to study that. A is the proportional limit, B is the elastic limit, C is the yield point. D, this is C and D are both are yield point. One is maximum stress is there called as upper yield point, lower stress is called as lower yield point. E is the ultimate point, F is the fracture point. Now you can see the stress formula and strain formula, how this stress strain diagram will get by conducting the experiments on the tensile specimen. Right? Next we discussed a Hooke's law. Within the elastic limit, stress is directly proportional to strain. In order to remove the proportionality, we need a constant. That constant is Young's modulus. Right? Young's modulus or proportional modulus of elasticity is a ratio of stress by strain. That is Newton per millimeter square. Next, for different material, how the stress strain diagram curve is there. For ductile material, you can get a smooth curve. For brittle material, you get only a straight line. For ductile material, it undergoes a plastic region. Failure takes place due to plastic region. For brittle material, there is no intimation for the plastic region. Only elastic region, it failures. Now again we discuss what is by engineering stress and engineering strain with respect to original cross-sectional area or that is instantaneous cross-sectional area. At particular instantaneous nothing but at particular time what will be the state of cross-sectional area it is. Then we discussed about material properties. In that very important one is mechanical properties. These are the mechanical properties also we discussed, right? And we discussed about in this class, today's class, mechanical members such as bars, trusses, beams, shafts, columns, and also we discussed about syllabus. In from next class onwards, we keep one rough notebook and we'll go for derive that some you consider in the first module the bar, mechanical member, then throughout our mechanics of material. We'll discuss only that when external load is applied on a body, what will be the internal effects. Internal effect means one is internal resistance force over a cross-sectional area is called as stress. Then change in dimension of a body takes place, then it's called as a deformation. Throughout the subject, we're going to determine one is stress, another one is deformation. Clear? Clear? On the different mechanical components or aerospace components. Okay.
Okay, sir.
Yes. Any doubts?
No, sir.
No doubt.
No.
Okay. Yeah. Janvi. Janvi is there? Janvi or Janu?
Yes, sir.
Ah. Now, so now tell me some of the, okay, yeah. In your house, yes, in your
Yes.
house, now which are all the components comes under beams?
Mm, fan.
Okay, wings of a fan. Okay, next. Be fast. I have only 5 minutes.
Turbines.
In your house, you use the turbines,
Handles.
handles, door handles. Okay, next. That's all.
Yes, sir.
Okay. Is Manoj K. Manoj K. Manoj K is not there. Mallana Gowda.
Sir.
Manoj K.
Hello? Yes, sir.
Ah. Now give me some examples for trusses, ma'am. Where you have seen the trusses? Hmm? You not listen the classes, ma'am? Okay, have a bicycle, a motorcycle. Manoj K. Next, Mallana Gowda. Naveen.
Sir. Hello.
Naveen.
Yes, sir.
You have a bicycle, man?
Yes, sir.
In bicycle, if you apply a brake,
Yes, sir.
right? So okay, if in your bicycle, so the handle will comes under which type of component is?
Sir,
The
handle.
handle or the brake system, the braking you apply the lever,
Trusses,
comes under
sir.
which trusses. The handle, if you are applying the handle that is perpendicular to the axis, right?
Yes, sir.
Yeah, the handle will come under which type of load it is?
1 minute. In axial load, sir.
No, it's not axial load. It's a transverse load. In a handle, if you turn this, if you go for left side, right side, if you turn like this, means it comes under which load it is? A
Transverse
transverse
load.
load. Means it is
Okay, sir.
what type of it is? Component. The handle will come under which type of mechanical member it is?
Sir, I didn't get you, sir.
In a handle, if you go for left turn or right turn, if you turn that handle of the bicycle or motorcycle, right?
Okay.
Now you are
Yeah.
applying a load perpendicular to the member, perpendicular to the axis of the member.
Okay, sir. Truss,
Which
sir.
member it is? Which member it is?
Truss.
It's not truss. It comes under beams.
Okay, sir. Sorry, beams.
A brake also. If you apply a brake, the brake lever. You're applying brake. If you're applying a brake in the brake lever, what type of load acting here? A transverse load on the lever. That is also comes
Yes, sir.
under beam.
Okay, sir.
Yes, Nisarga.
Yes, sir.
Ah. Now tell me,
Sir.
yeah, give me example for shaft.
Shaft, sir. Transmission shaft, sir.
Transmission shaft. Okay, take a bicycle or motorcycle or car. Where we are seeing the transmission shaft?
Transmission shaft. In cars, sir.
In cars. Tell me the where we see that shaft.
Wheels.
Yeah, wheels. We call it the axles. The axles are becomes a shaft. Is a rotating component, right?
Sir.
Okay. Next, Pawan Kumar. Pawan Kumar. Pradeep K.
Sir.
Yeah, Pawan Kumar. Pradeep K. Give me example.
Pradeep K.
Yeah, both of you. Give me example for bars.
Sir.
Mechanical members. Give me example for bars. Pawan Kumar, go ahead, man. Pratik. Rutuja. And I don't know who is this unknown user. You.
Hello. Hello, sir.
Yes, Pawan
Sir, I
Kumar,
am
go
the
ahead, man. Unknown user. Who is that?
Vijay Simha, sir.
Put your name, man. Vijay Sima. Okay, from next class onwards, put your name. Otherwise, we
Yes, sir.
think that unknown user means someone has, okay, unknown person is seeing that means we are some higher authority may be monitoring our classes. That's why we feel like that. Okay. City Raj. Yashwant D. Raj.
Yes, sir.
And last
Yes,
one
sir.
is Yogesh P. Yeah, Yashwant D. Raj. Give me the example for
Yes,
columns,
sir.
ma'am. Yes,
What,
be
sir?
fast. Give me example for columns.
Example for column.
This is why you are facing a problem means you're not attending classes, you're not listening to classes properly. This is the answer. Okay. Not attend classes. This is the problem. Yogesh P. Yes, Pawan Kumar, unmute yourself.
Sir, your voice is not audible, sir.
Who is that? Yashwant.
Sir, your voice is not audible properly. Your voice is breaking.
Okay. Yogesh P. Okay. Yes, Yashwant D. Raj. Come back.
Yes, sir.
Ah.
Yes, sir.
Yes, tell me my problem. My voice is not audible.
Now it's audible, sir.
Now is audible. Okay. Can you give me the example for columns?
Columns, pillars, sir.
Okay.
Pillars and
Okay. Just I'll give one practical application.
yes, sir.
Suppose you are sitting on a chair.
Okay, sir.
Okay, it may be plastic chair or metallic chair.
Yes.
Yeah. Now on the chair, which part of the chair subjected to which part in the chair is comes under columns?
The four, I mean that
Yeah.
which is
Left.
placed on the floor,
Sorry.
which supports for sitting, sir. Those four legs,
Yeah, four legs comes under
columns.
columns. Yes, good man. Okay. Is any other doubts, students, regarding today's session?
No, sir.
No doubts?
Sir, you send this note, sir, which you taught today.
Yeah. Definitely, I will send you, man. Already you have the notes. Yesterday, what I sent, that you have
Sir, this
already.
beams one, sir. Beams and this one
Material.
today.
But the bars, beams, stresses, when you start doing our syllabus, then you automatically in the first or second sheet, it's there. Okay. Any other doubts? Yes. Shall I wind up the class? No response? Okay. Thank you guys.
Attendance, sir.
Yeah. Okay. Thank you guys. Thank you for attending the classes. We'll see in tomorrow class. And in the tomorrow class, bring one, keep separate one notebook for mom subject, and you should have a calculator, pen, pencil, eraser. Okay, on notebook. Okay, first we'll go for derive the equations, then we'll go for solve the problems on that. Okay, so be ready all these things with you in the next class. Okay,
Okay, sir.
thank you guys. Thank you one and all.
Thank you, sir.
Now I'm leaving that class.